Hello YouTube, my name is Kate Anderson and today I will be attempting to explain wormholes in a simplified fashion. Wormholes can be pretty tricky to explain, and it doesn't help that sci-fi gives us an incorrect understanding of wormholes. That is, if we knew they existed. Like I said, we don't actually know that wormholes exist. Wormholes have been hypothesized to exist by Albert Einstein in his general theory of relativity. His math says that wormholes could or should exist in space. Einstein's general theory of relativity also successfully predicted black holes. Wormholes are found in black holes. The theory of wormholes is that they bridge space-time from point A to point B. Instead of going with the arc of space-time, they just go through, making the distance shorter. Now, the problem we have understanding wormholes is wormholes are actually four-dimensional. Space is three-dimensional. Wormhole would be something else. So we have difficulty understanding the concept. Some people will explain wormholes like this. This isn't a very good picture. I'll see if I can get it closer so you can see better. Oh, this will work. Alright, so before I begin my explanation, we're going to have to crush some dreams. Wormhole travel is not possible. It can't be done. There are two reasons for this. The first one is wormhole size. Wormhole size is only 30 centimeters. It gets no larger than that. The other problem is wormholes are incredibly unstable. According to Einstein's theory, you would never be able to get anything more than halfway through a wormhole. Okay, what happens is the wormhole just collapses. Anything inside is lost. There's literally nothing there because it's in between space. It's gone. So another problem we have with how wormholes are conventionally explained is people think that you will travel faster than light if you can travel through a wormhole. That's not true, right? So brown, in this instance, will represent light. Okay, so assuming that you could travel through a wormhole, which you can't, if you were to travel through a wormhole, going from point A to point B, and light left, a beam of light left at the same time as you, traveling from point A to point B, and did not go through the wormhole, you would be through the wormhole and be done. The light would still be traveling through space. If, however, the light were to go through the wormhole with you from point A to point B, you still left at the same time, the light would just get through the wormhole like that. You would still be traveling because light always travels at the same speed. The wormhole does not actually accelerate you faster than the speed of light. That's not true. So the problem with this representation of a wormhole is it's only two-dimensional. It's just a drawing. So this next segment will hopefully help you to understand better how wormholes function. Okay, so this is a three-dimensional depiction of space-time and a wormhole. The wormhole would be four-dimensional in reality. This one is only three-dimensional. That's can't be helped. The object will be represented by this capsule that will go through space-time and then through the wormhole, and hopefully it will help you to understand how wormholes are unstable and why something can never make it through.
For this segment, I'll be doing a voiceover. It's going to be easier than trying to talk and manage this capsule at the same time. So on the right, there's the capsule. It's going to enter from the bottom right. This represents an object moving along through space-time. Assuming no wormhole, it would continue around the arc of space-time. And here we have what would occur were the capsule to enter a wormhole. As you can see, the capsule went up and got stuck. This would represent the object going up into the wormhole collapsing and stranding the object. This next segment is just me moving the capsule around inside of the wormhole. Were something to go into a real wormhole, there would be no chance of it ever coming out again, as is the case with this capsule. Thank you so much for watching. I hope you learned something from my video. Curiosity is a gift. If you still have questions, by all means, continue in your quest for knowledge.